Welcome to this at least third presentation on chaos engineering in this event, I think. But it's great that I'm going after the other ones because they introduced a bunch of things that I don't have to introduce again. So that's a good thing. And I hope my talk will be helpful for you to think about this a bit differently. That's also something that I want to introduce here, like chaos engineering, the way we practice it, at Datadog, but also we can practice it in most large engineering companies, can be a bit different than what we used to have in mind. So I will start with a small introduction of definitions of chaos engineering that you can find there and there. And I picked, of course, one of the most known famous ones, which is the principles of chaos engineering, saying that chaos engineering is a discipline of experimenting on a system in order to build confidence. I picked some other ones. There is this one from OpenText, for example. It says that it's the practice of intentionally injecting faults into a system to test its resilience. Or Dynatrace, which says that chaos engineering is a method of testing distributed software that deliberately introduces failure and fault scenarios to verify its resilience, and so on. So in the end, if we look at these definitions, and you can find many other ones, you will find a few common denominators, let's say, which is that chaos engineering is about experimenting on systems, about practicing on intentional faults, or verifying systems resilience against random disruptions. And to me, this is where we might be missing the point of chaos engineering, actually. And I will continue with chaos engineering being the fear of fault testing. If we look at the available toolings, you will find a lot of things. So you have a bunch of famous ones here, Gremlins, Litmus, Chaos Mesh, Chaos IQ, and Harness is also the other one. And we even have our own stuff. We have an open source fault injection mechanism if you want to look at it. So if you want to do fault injection, that's something that you will find pretty easily. And now, do you know what's the main reason, the main challenge for adopting chaos engineering? And if you don't know, you look at Gartner, and it's the fear of actually breaking things. So we are selling chaos engineering with fault testing and breaking things on purpose, while on the other hand, the main challenge for companies to adopt chaos engineering is the fear of breaking things. And so we have this duality, and we can ask ourselves, is it always needed to actually cause disruptions to do chaos engineering? So that's the introduction. I'm Joris, I work at Datadog. I am actually staff engineer, so like my presentation says engineer manager, but I moved out of management recently. So I joined SRE in 2018. I focused mainly on chaos engineering, like the technical stack. Then I focused on building the chaos engineering teams at Datadog that we'll talk about at the end of this presentation. And as I said, recently I moved to staff engineer, so I'm going back to the IC track, going back to some more technical stuff, focusing on large-scale resilience issues at Datadog. So of course, still dealing with chaos engineering, but trying to expand that to other things that we have. Okay, we'll talk a bit about chaos engineering as an old practice, because that's a trendy for a few years now, but that's a trendy word like SRE and all these things, and it looks new, but actually it's something that we've been doing more or less in all industries. So we can take some examples that I put a bit randomly, but we can see here many things about testing limits of systems, about finding breaking points in systems and getting ready to respond. But if we try to extend that, and those three pictures, actually what we are doing is not really that. What we are doing is, for example, on the top left is testing the limit of the system, but in its nominal conditions, so like someone sitting and getting up repeatedly from a chair, for example. Finding breaking points under pressure, so eventually it could be what we expect from the system, but actually going a bit further into the way to use it. The last picture on the bottom left is about someone doing a firefighting exercise, and it's getting ready to respond, yes, but in extreme conditions. So all these things, if we try to extend that to what we do with chaos engineering, we can try to think of a system on which we will experiment. So I try to put my thinking process and the way we do it at Datadog in a small diagram that is not very user-friendly, I'm sorry. But we can think of this spectrum of a system, and we'll try to put something on it. So on both sides, we'll find the conditions. On the left side, we'll find the middle ones, and on the right side, the extreme ones. So basically, the pressure is increasing along the way of the spectrum. On this spectrum, we can put a bunch of things. So for example, breaking points. There is only one here, you can find multiple ones, but this is when your system will start to flip between what it knows how to do normally and what it has to do in extreme conditions. This breaking point, it can change depending on what you do with your system. You can bring improvements or you can have regressions, and this needle will move along the lifetime of your system. On both sides, you will find various scenarios that you can put. Scenarios are very famous in chaos engineering. They are what we use to do experiments. So I put a few ones there and there, like latency, like normal latency, let's say, some dependency failing for a short amount of time. And on the other side, you will find the more extreme scenarios, like latency being higher, having issues with dependencies for a longer time than expected. So basically, what we do on the left side is that we are making sure that the system is actually answering to things that it knows. And if we make the parallel with property-based testing, it's basically making sure that we know how to define predicates of the system. And on the right side, we have the extreme situations in which the system can actually evolve in. And so we are trying to get ready to operate in such things. So we are doing more or less operational testing. So with all this in mind, and if we try to think a bit further about chaos engineering, what we do is actually a bit more than just experimenting. One thing is that we try to understand the nominal and the extreme conditions the system will actually run in, and also understand the breaking points. That's the first thing. Second thing, we will define hypothetical scenarios. So hypothetical, eventually coming from real scenarios, but at least things that we think could happen, and even the normal ones. So even the ones that are actually supposed to happen. We will establish predicates. So predicates as things that shouldn't change. And they are very important because they define the actual resilience properties of your system. So how it's supposed to actually behave in conditions that are not normal. And finally, we write down emergency runbooks. Emergency runbooks, which are useful for an organization. And of course, we'll come back to that, but an organization is a system as well. And how they can operate the system in production when there is something happening that isn't expected or that is expected but can't be figured out by the system itself. So in the end, if we look back at this, chaos engineering is not only about breaking things on purpose. If to some extent it's more about formalizing knowledge about a system in the various situations it can face. So we'll keep this in mind, and we'll talk a bit more about this formalization of resilience. If we think about it, if we think about incident management, which is for some reasons, business reasons, something that all companies are implementing even before chaos engineering, it's not that different. When you declare an incident, it's because something drifted from your expectations. Usually, you don't declare an incident if everything is going as expected. For example, if your system is able to lose a dependency for 30 seconds, you won't declare an incident because it lost its dependency for 30 seconds. You just let it go, and that's it. So the way we formalize this drift is through incident declaration. But the truth is that your system keeps having small incidents there, and there is always something happening. You just don't notice it or you don't care about it because it's part of your natural, everyday life. But network latency is fluctuating, dependencies are fading, or even just restarting because someone is deploying something in microservices. The load can spike because of the time of the day, because of an event happening. So all these things can happen and will happen anyway. And most of the time, you just don't care. But when you care, that's when you start to learn things. So there is this small loop, I don't know how to call that shows when it starts to drift from reality. And so what you do first is that you declare an incident, because this is the first action that you want to do. You declare an incident, you try to learn what's going on, how to react fast. Once it's done, this is when you start to learn a bit more deeply. You will look back at things, you will try to understand the root cause, you will try to understand why it drifted from reality, why your expectations were false. Hopefully you write a postmortem also that will help to define action items. Action items are supposed to realign the reality with the expectations, and if possible, please do not realign expectations with the reality, because otherwise you are taking the easy way, but usually that's not what we want to do. So this is what we do for incidents. And at this point, why chaos engineering shouldn't be the way to just formalize that at all times expectations are aligned with the reality. Because if we go back to this, as you can see, it's a loop. So once you are done with your action items, you wait for 1 week and you have a new incident, because once again, expectations drifted from reality. At Datadog, and what can be done in most companies, we can implement some reality steps that will help you to figure out what are your expectations and especially make sure that they are always met at all times. So of course, the first step is to actually understand the reality. And it can be done via an experiment, it can be done via fault injection, true. We'll talk a bit about that after this, but it's not mandatory. So what you want to make sure is that you have defined expectations. They can also be theoretical, which is interesting. They don't have to come from just the reality. You can build your expectations and then figure out why they are false. But once they are done, eventually we realize that your reality is not aligned with these expectations. So we go back to the thing that I showed just before. So you will have a few iterations. It can be one, it can be multiple. Datadog, we have stuff running for 3 years now to align expectations at large scale. So it can take time, it's not a big deal, but you want to go with small iterations so at least you can quantify and you can solidify some of the steps. Once you're done with that, the reality is aligned with your expectations at least one point in time. So you conducted a game day, for example. Now it's done, everything is aligned perfectly. Fair enough. What do we do? You can keep it like this, but in 2 weeks from now, it's gonna fade, and that's pretty much it. Or you can do the famous shift left. I don't know how to call that better than that, but you can go with the shift left and try to bring that closer to what we know in software engineering, which means testing. And then what you want to do if you are able to do some testing is to test continuously, of course, because when you have CI/CD, what you do is that you have unit tests happening all the time. So if we look at this, we have two kinds of chaos engineering, let's say. One is about experimenting, one is about chaos testing. And the actual first one is something that you don't need fault injection to learn from that. You have incidents, for example. That's a very good way of learning things. You have tribal knowledge, you have your internal knowledge, you have all these things. You can define all that without fault injection, and fault injection can actually happen at the very end. So it goes back to my title. That's what we try to do at Datadog, and what we keep trying to do is to move from this experimentation mindset to something which is more about continuously verifying the resilience properties of your system. The thing is that continuous is very arguable, let's say. So when should you test? At least in two occasions, of course, on a local change and on an environmental change. So the thing is that a local change is something very easy. We know that with software testing, and every time there is a code change, you want to test all your predicates. That's it. Now about environmental change, that's something that is really hard to catch because it can be your dependency changing its way to handle timeouts, and you don't know it. So for these things, you want to test on a regular cadence, periodically. It can vary, of course, it can be every day, every week, every month, it depends. But that's something that you want to keep trying, so at least you can provoke the drift from reality as soon as possible. So for the last part, I will talk a bit more concretely about how we did that at Datadog, because that's a lot of theoretical stuff, which is interesting, but it's not that simple to implement. So for Datadog, like for most engineering companies, we started with one SRE team doing everything. We were doing some Terraform stuff, we were doing some load balancing management, we were doing some chaos engineering, SRE principles, everything. At some points, we came with one of the biggest challenge of large engineering companies. We have a lot of engineering teams. They should all care about their security and their reliability. So I put security in there because SRE at Datadog is part of the security department, which gives some interesting collaborations. So we think it's the same for security and reliability. The thing is that they are not experts. And so, of course, there is one question that we want to ask ourselves, which is, how do we turn them into experts? And the thing is that we can't. We don't and we can't. Because if we want to do that, of course, all the other microservices providers at Datadog would like to do the same. Why are engineering teams not Kafka experts? For example, we have a lot of Kafka at Datadog. They should be Kafka experts, but they are not. Why aren't they Postgres experts? That's always the same question. The thing is that we can't make them experts. So what we can do, we can eventually enable them. And we try to do that with two things. The first one is that we reduce the initial investment. So the teams are more willing to invest into chaos engineering and SRE because it's easier for them. And we scope, and I think that's maybe the most important part, we scope this practice to something they know, which is, in this case, their services. Because they don't care about testing very large-scale stuff. They don't care about emergency procedures that are company-wide. They don't care about that. They care about their service that they deploy every day. Because when there is an incident, they are the ones responsible for it, and they are the ones being on call, being paged, and spending their nights trying to troubleshoot things. So that's what they care about. On the other hand, we have experts, and the experts are ourselves and other SRE teams. So we also need to rely on them and on us to provide resilience baselines that all engineering teams can follow without really to have to think about why. So we created the Chaos platform. That's one more UI. I just show it for the sake of showing it, but that's one more UI, gathering a bunch of tools and a bunch of practices. So as I said, we have a bunch of internal stuff that we built. Some is open source, you can look at it. Honestly, it doesn't matter. That's one more fault injection system. What matters is that we oriented this UI around a few principles. The first one is being feature complete because we have experts and we need to allow them to do what they know to do. The second one is golden path because we have non-experts and we want them to be able to go to what matters without having to think how and how much it will cost them. I can provide some examples for this one. We generate for all engineering teams dependency failures that they can pick. So they have a catalog, they can pick dependency failures because they are auto-generated. They don't have to figure out how to make them, how to do them, how to apply them, why, and so on. They have that, they can pick it, apply it, test their thing. And we align that with known work units, as I said, services. And the way we did it is actually the way we implemented our chaos engineering teams. So we have 3 different groups in chaos engineering. The first one is about fault injection, and that's something which is interesting. Fault injection is an entire team, just working on fault injection mechanisms. They don't care about who will use that. They care about what they can provide in terms of fault injection techniques. The second one is about SDLC integration. How do we integrate fault injection into SDLC that we have at Datadog? So it can be on release, it can be on the different environments that we have, all these things. And what's interesting there is that I can't show it there because it would be a bit too big, But we don't only integrate fault injection, we integrate other parts of Datadog. So for example, we have an API platform team providing all APIs at Datadog, and they provide load testing for APIs. This team, SDLC integration, will integrate load testing as if it were a fault, actually. So anyone at Datadog can use load testing in their API as a fault, and they can link that to resilience property testing and all these things. And it's the same for many other things, like draining services is considered as a fault, for example. And the last one is the engineering enablement, so chaos enablement team. This one is focused on making sure that we can take baselines and apply them at scale at Datadog, making sure that we have the right teams at the right time and at the right place. And this is how we try to create this synergy, let's say, of chaos engineering at Datadog. And I try to put some, practices around that. If we bring all these things together, like for example, fault injection and SDLC integration, we try to provide property-based testing for systems resilience. On the other side, we have operational testing, like for example, game days. And on this side, we have resilience baselines. And there is one thing remaining here, is the large-scale testing, because I mentioned that large-scale testing, most engineering teams don't care about that, but we as a SRE do care about that. So we started an initiative years ago that we call large-scale game days. I think that's a long name, but it says what it has to say, is how do we take a game day and we apply that to many different teams. So we have multiple ones. I put two examples. One is about disaster recovery. I think that's the most known one in most companies. At Datadog, it's about 200 engineers for 8 hours of exercise, so that's a pretty big one. We have people in the US and in Europe, so we also have rotations to manage and all these things, so it's pretty interesting. And it's about 150 test cases that we have to validate. Test cases being really about what happens on the customer side of things when we want to recover. We have the same efforts for the null failure. That's something that we've been running for 3 years now. How do we enforce the null failure resilience at Datadog? So what happens when we fail a zone, of course. But what we want to focus on, once again, is not about what happens when we fail a zone, is what do we know to do when a zone is failing. I will finish with one thing. Humans are also complex systems. That's something that was mentioned also yesterday by Scott, I think, if I recall correctly. The thing is that organizations are made of people, teams, groups, and all these things, and they also experience disruptions. And when you have an incident, they have an incident. So we all have limits. On-call fatigue, for example, it can lead to mistakes. It can lead to incidents into the incidents. 3 years ago, I can't remember. I think 2 years ago, we had a very big outage at Datadog that is very known internally. And it took 3 days of rotation. So I'm part of the core IC rotation. It's a rotation where we usually have 12 hours shift and we operate into all large-scale outages at Datadog. So we are pulled in all big outages. We deal with basically engineering teams, leadership, so like C-level people, and external communication, so like status pages, support, and all these things. So we try to make the liaison with everything. When this happened at the end of the third day, we were doing 1 hour rotation because basically we exhausted the whole pool of people. We were like 50 people. We exhausted the whole pool of people able to operate in such an environment because, of course, we needed multiple core ICs in a row in the incident. So that's how we started to test the limit of humans. At some point, we were just trying to make our best. We also faced challenges to make decisions. Same thing, when we had to rotate over 3 days, making sure that the context is known, is understood. When you have an incident which has thousands of messages. If we take the example of disaster recovery, it's something like 80 different work streams. So work streams being Slack channels to operate in the incident. And so you have to coordinate all these things. So you lose context, you make decisions that are not necessarily meaningful because it's very difficult to actually keep things going on. We are sensitive to changes. So as I said, context switching is something, you lose some context, but it also introduces delays into incidents. It can lead to burnout. Some people are just not able to operate properly into stressful situations. But sometimes you have to face stressful situations. And finally, we all rely on the knowledge that is available to us. And this is unfair because, of course, in incidents, sometimes you can take the same incident twice, depending on the people in it. You will have different outcomes because some people will know things and will take shortcuts. Some people don't know. So you are dependent on the available knowledge, the written one, but also the one you have in mind. And it can be very easily outdated. And yeah, as I said, likewise for technical systems, human systems, are facing incident scenarios that are unique every time. Unique in the way you feel, the amount of sleep you had, the people you are working with, because that's a fact also. Sometimes you will have people you prefer, let's say, and that's it. And it's going to be easier to discuss with them and share context with them. All these things make the scenario unique. So it's also important to think about that when you do chaos engineering, because chaos engineering is also about making sure that people have all the things they need to operate in an incident situation. And you can do chaos engineering on people without having to deal with systems. We do that at Datadog. We call that incident rails. That's one more word. But that's one way to deal with it. Like we create a fake scenario and we involve C-level people, for example. And there is a reason for that, is because when the CTO is joining an incident and starts talking, no one is speaking. Like, just everyone is listening and no one even dares to answer. So that's the thing that we're trying to do. We do exercises where we put C-level people and we try to make sure that first they do not disturb incidents, but also people are not afraid of discussing with them and just answering their questions and making sure they can collaborate in incident like any other people. So yeah, I can conclude on these things. So first of all, chaos engineering to me is more about formalizing the knowledge rather than actually breaking things. I think if you are able to formalize the knowledge, you don't have to break things. You can use real life broken thing, I don't know, like incidents, for example. Fault injection is not necessary to start. It's definitely a good way to make sure that your resilience properties are respected. And of course, it's also a good way to create opportunities. If you are able to do that and spend the time and the money on that, do it, because it will create more learning opportunities. But you don't have to do that if you're not comfortable with it. What works at small scale doesn't necessarily work at large scale. That's one thing also that large scale testing is trying to help with. Individual testing is very great, but of course, it's not because everyone is testing individually that at large scale it will work as expected, and especially because at large scale you have human complexity to deal with, which is much more difficult than systems. And all kind of changes can have unpredictable effects. Like butterfly effect is something also in technical systems. We want to make sure that this is known. This is why large scale testing is very important. And I finish on humans or complex systems. Yeah, we need to take care of that. So yeah, thank you. I hope it changed a bit the way chaos engineering, and especially that you see one step further chaos engineering and how it can actually help with resilience, formalizing and property testing in your company, and also the way you can pair that with incident management. Okay, thank you.
Any questions?
So I'm an engineer who possibly doesn't do chaos engineering as much as I should because I'm afraid of causing actual problems. In terms of the initial engineering phase, when you're trying to figure out what expectation should be versus the testing phase later, is the ideal for experimenting that you push this, that you like keep ramping it up slowly till you push the system to the point where something actually breaks, versus with regular testing, you have it at like the highest point it can be without something breaking, just as a regression check? Is that the ideal?
Yeah, exactly. That's what we try to do. So the idea is to, like, what we do, well, the way we do it at Datadog is that we generate scenarios. So they are progressive, so people can test different things. We try to do something new also with the rise of AI, of course, as everyone is trying to do things, is that we generate thousands of scenarios with very small changes so we can apply them for a long time, like 4 hours. And we try to detect when states is changing a bit more automatically. So it gives more insights. But ultimately, that's what we've been doing as humans as well, just, of course, at a smaller scale than what AI can do. But it's this. We just try to change minimal things and understand the effect it has, but especially understand when the state is changing from everything is fine and we should create an incident. Yeah.
Thank you. Thanks for the talk. It was interesting to hear about different people can differently understand the same data. So I was about to ask, did you think of replaying incidents? Incident is just a bunch of telemetry that we observe as engineers sitting at the laptop. Did you sessions where you replay the incident and other people in the room seeing the same things, but you already know the root cause?
Yeah, we do. So we did actually. I think it's not something we are doing for now, but that's something that we did in the past. It's definitely interesting, and especially as an observability company, what we've been doing is to fake observability data, because it's enough actually to reproduce an incident. We don't actually have to break systems, because what we do when system breaks is that we look at our data and we try to figure out, is it broken or not? So what we try to do is to just come back with incident data, like observability, metrics, logs, and so on, that are showing system breaking, and we let people interpret that, because that's also one key criteria of incidents. It's about interpretation. People are interpreting data, and you take the same data, you put that in front of different people, and they will interpret a different way. And once again, it also goes back to the knowledge you have in mind, because some people will see the data and will say, yeah, that's because of this, because I know it. Some people will look at it and will have to go like 3-4 steps further to understand why the data is showing this. So yeah, definitely, it's something that we've been doing for some incidents. Yeah.
My question is about the implementation of chaos engineering into development workflows, not just production incidents. So for example, I'm applying a patch or deploying a patch and the pipelines are broken, especially with the cloud native dev workflows. What if I'm trying to deploy something and the pipeline CI/CD is kind of broken? So what are your thoughts about bringing that into more of dev workflows?
Yeah, that's something that we also try to push for. The way we do it, so at Datadog, we have deployment workflows, and we have what we call monitor gates in the middle. So what we do is that monitor gates are looking at Datadog monitors, And when there is something which is going from green to red, it automatically rolls back the deployment. So it's a bit, it's a bit extreme, because anytime there is something which doesn't act as expected, we will roll back without, like, before even trying to understand why. But that's the way we implement it into the workflow of deployments. But I would say usually what we inject there is, it's all the things that we know shouldn't break anything. That's also probably one property of chaos engineering. Usually you do fault testing in these environments when there is nothing new to learn. Like, basically you know everything and you just want to make sure that what you know is always true. So that's when you start to do fault testing in these scenarios. Yeah, hope it answers the question. Yeah, okay. Yeah. Okay, thank you. Thank you very much.